Hello everyone. In this session, we are going to discuss about PN Junction Diode. Before going to the discussion, we'll see what are the application of PN Junction Diode. Normally, the PN Junction Diode it is used in photodiodes and it can also be used as a solar cell. And the main and important application of a diode is it can act as a switch. Okay, so normally when it is in forward bias, it will be used in on condition, and when it is in reverse bias we can use it in off condition, and it is used for LED lighting applications. Okay, so what is PN junction diode here is it's a interface or boundary between two semiconductor material, that is we can have a p-type material and n-type material, and when we are combining it when you're combining it, we'll get the PN junction diode. And the junction is nothing but an imaginary one. That in the place of junction, we'll have a in this place, right? In this junction, it's a we'll have some barriers present there. That place we'll call it as junction. Okay. So, and how it is formed here is we'll take a p-type material and we'll take an n-type material when combine it. The end of the p-type material we'll call it as anode, and the end of n-type material we'll call it as a cathode. And so this is your symbol of PN junction diode. So this is your anode, this right line part is your cathode. And how it works, we'll see how it works. And before unbiasing, that is before giving an external supply, how it works here is, so we are taking a p-type material and we are taking an n-type material. This is before biasing, before giving any external supply. So the p-type material, the majority is holes. Holes is nothing but it's the empty space, that how we can say it. There will be electron. When the electron starts moving, the empty space where the electron is present, we'll call it as holes. So in p-type material, the majority carriers is holes, and n-type material, the majority carriers is electrons. And the minority carriers is vice versa. In p-type material, it is electron, and n-type material, it is holes. It is positively charged. So what happens? The holes is positively charged and electron is negatively charged. The minority carriers on the both end, right? The minority carriers on the both end attracted towards the region, that is the junction. We'll call that as junction, right? So it gets attracted and it forms a barrier. That one we'll call it as a depletion region here. Okay, this is before biasing, that is before giving external supply. Now when we are biasing it, forward biasing is nothing but when we are connecting n-type material to the negatively charged and p-type to a positively charged, we'll call it as forward biasing. So here when this forward biasing is happening, the depletion region, right, the depletion region starts to reduce. Okay, because the electrons get attracted and there will be a flow of electrons. Since there is a flow of electrons, we'll have current, because the current direction is opposite to the flow of electrons. And next comes the reverse bias. So the reverse bias here is with the that connection direction will be opposite to the forward bias. So here the n-type material is connected to the positive terminal of the battery, and p-type material is connected to the negative terminal of the battery. And here what happens here is, here the potential barrier get increased. Okay, and so ideally we see there will not be any flow of electrons, but practical condition it does not exist. There will be microampere of currents passing through. And now we'll see characteristics, how the characteristics work. So this part, this for by forward biasing. Okay, this is forward by characteristics by forward biasing. So what it happens here is, this is practically so the current, right, it does not start increasing initially. At a particular voltage it starts increasing, the current start increasing. So at which points the current start increasing, that point we'll call it as a knee voltage. Okay, so it is 0.7 for silicon and 0.3 for germanium. And for reverse biasing condition, your current actually ideally there will not be reverse diode conducting in reverse bias, but practically there will be some microamperes passing through it. So what happens at a particular voltage, the current starts increasing rapidly. That is, there is a reverse voltage breakdown occurring there. So that's all with the characteristics of PN junction diode. So the symbol here, the symbol of PN junction diode is nothing but this, right? So this is your anode and this is your cathode. So that's all with this session. Thank you.